Most of the time, when we see problems asking about waves passing through openings, it's usually specifically about light waves. This problem is asking about water waves, but the same principles still apply. There are two openings through which the water wave in this case can pass, and these openings are separated by a distance d. And we're being asked about the angles that these waves reach, the angles that they're at some distance away from the board where the slits are. Where the angle theta represents the angle between the horizontal, and described as the straight through direction of the board, with wherever the fringes are. This problem is specifically asking about cases where there is little to no wave action. So in other words, we're looking for the places where there aren't fringes. We're looking for destructive interference. So the equation for destructive interference says that d, the distance between the slits, multiplied by the sine of the angle, is equal to m plus 1/2, so the order of the fringe plus 1/2, multiplied by the wavelength of the wave. And we are given the wavelength in the problem because the problem tells us that the water waves have crests that are 4.5 centimeters apart from each other. So the problem's asking us to find some angle, so we're going to algebraically rewrite this equation to solve for theta. So first off, dividing both sides of the equation by d, we can see that the sine of theta is equal to m plus 1/2 multiplied by lambda divided by d. I'm actually going to plug in some of the values we were given in the problem to make this a little easier. So this m, we don't know what m is yet, plus 1/2 multiplied by the wavelength, so that's 4.5 centimeters, all divided by d, the distance between the fringes, the distance between the openings, which is given in the problem as 7.5 centimeters. You don't need to do a unit conversion to convert from centimeters into meters because there's 1 centimeter in the numerator and a centimeter in the denominator, so they just cancel out. And simplifying this, this tells us that m plus 1/2, all multiplied by 0.6, is equal to the sine of theta. And then, of course, to get the angle theta on its own, we need to do an inverse sine. So theta is equal to arc sine of m plus 1/2 multiplied by 0.6. So now we have a formula that'll give us different angles for different values of m for which there is destructive interference, for where there is little or no wave action. So let's start plugging in values for m to see what these angles are. And recall that m can have integer values going from 0 to 1 to 2 and so on and so forth. So let's start plugging these values in. So we'll start where m is equal to 0. So for theta 0, it's the inverse sine of 0 plus 1/2 multiplied by 0.6. Put this into your calculator, and make sure that your calculator is in degree mode, and we get an angle of about 17 degrees. So that is our first answer to the problem. Now let's plug in for the case where m is equal to 1. So arc sine of 1 plus 1/2 multiplied by 0.60. And this gives us an angle of about 64 degrees. Now let's try plugging in 2 for m. So theta sub 2 is equal to the arc sine of 2 plus 1/2 multiplied by 0.6. And notice in this case that if we simplify the stuff in the middle, this is equal to the arc sine of 1.5. So if we were to put this into a calculator, then we would get an undefined error. The inverse sine function does not work this way. And even if it could, it wouldn't make physical sense anyway, because the arc sine of 1.0 is equal to 90 degrees. So beyond that point, the waves aren't going to be making contact with the board anyway. Or rather, the waves are not going to reach the position 3 meters away that the problem's asking about. So yeah, because the arcsine function does not accept values greater than 1, we don't need to worry about any angles beyond m equals 1. So the only two angles that answer this problem are 17 degrees and 64 degrees. So these two angles are our answer to this problem. And that is it for this video. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos like this. And if you have a request or a question, leave a comment down below, and I'll do my best to help you out as best as I can. That's all for now, and I hope you have a lovely day. Bye-bye.